So let's review quickly what we did last time and transition into what we're going to do. What we looked into last time was building a macro in Scala 2 and taking a macro and using that macro to parse a clause. And then once we parse the clause, return something based on the code that went into the macro. So that's what we did. That's what we did last time. So let's have a look at how to do this in Dotty. Actually, first, let's just review that in order to implement a macro in Scala 2, basically you need, roughly speaking, what is the equivalent of a header file and a source file, sort of, where the header file basically just defines the macro method. And by the way, there could be other functions in here. This isn't, you're not limited to, a macro method. You could do other things in here. So it's not quite a header file. But you can think of this as specifically for macros a header file. And then the source file that defines the actual method. Now, for Dotty, it's a little different. In Dotty, they have a construct as part of the language called inline. So let's have a look at how this works with Dotty, or Scala 3. So with Scala 3, let's open up VS for a second, and let's actually create a new project very quickly. So we'll just copy this build.sbt. Let's do that. Let's copy that there. And let's see. Build.sbt. Notice how I open Sublime Text from Linux into this exact window, or this exact directory. Let's see. And okay, fine. Name Dotty macro example. And let's pull in all the utilities that we had last time. That should do the trick. Now, let's make some directories. And let's start.
Alex, just a quick question. Do you think everyone will need to know the SBT build tool? Do you think they should?
I hope not.
All right, yeah. I was just checking.
So the Scala build tool. So basically, my spiel on build tools is that every single build tool that I've ever seen, I've despised. In the beginning, there was make, and I hated make. Then for Java, they made Ant, and I hated Ant. And then they had Maven. And then I somehow ended up being a quote-unquote build engineer for Maven, for like a team of 20 people eventually. And I hated that, and I hated Maven. I've written Maven plugins, so I've seen some of this stuff on the inside. Then I tried Gradle and I hated Gradle. Then I tried SBT, the Scala build tool, and I've hated SBT. And I have not seen one build system yet that I have not hated. So that's my spiel on build tools. SBT is the Scala build tool. It allows you to code in Scala. It's similar to Gradle in many ways, where it provides programmatic logic, right? Like the big criticism that they had of Maven was that, oh, it's not Turing complete, it's not Turing complete. In other words, you can't have programmatic logic. Well, Ant is Turing complete, sort of, but Ant is horrible, so whatever. But anyway, so Groovy then came back and said, okay, so what's good in Maven? The notion of build phases. All right, let's do that, and let's build Turing complete logic on top of that. So that's Gradle, and that's basically SBT. Whatever. Third generation build tools for what they're worth. But the point is that you just use this command sbt launch IDE, and the project should build. If it builds, it'll launch the IDE, or it'll launch VS Code. And that's the long and short of it. I can send around some material, some basic introduction to how SBT works. It's a big, annoying, crazy, bulky tool. Just like Gradle and Maven and every single other system out there. So that's all I want to say for that. If you've got issues with SBT, let me know. I'll try and solve them, or bang my head or ask whatever is needed. All right. Oh yes, excuse me. There's some additional settings. There's some additional settings that I just need to copy in here. Test. Oh, .ignore. Very important. Oh, actually, CD. Then there's this project folder that they rely on. Right, build.properties is important to have for some reason. And let's see, heat2 projects. Oops. Copy that project. And the other thing you need to have is plugins.sbt, and that's actually the most important thing because it defines the fact that you have the Dotty plugin or the Dotty compiler plugin. So that should be there too. Now I believe it should fire up. All right, you could have noticed some things appear. And here is our brand new Dotty project. And I'm going to commit this to GitHub once we've gone through it. So here's VS Code. You can actually do Dotty with IntelliJ right now. I think you need their probably latest nightly build because Dotty is still changing very rapidly, and the IntelliJ people are changing the IntelliJ Dotty plugin very rapidly along with them. So if you want to go that direction, get the nightly build for IntelliJ. I don't think that it does the right thing for Scala 3 macros or Dotty macros. I don't think it necessarily does the right thing. But anyway, new Scala file. What's that? I guess that didn't do anything. So let's just make the package. Oh, whoops, that's supposed to be a directory. My bad. Very creative. All right. And by the way, this does not have to mirror the name of the file. You can put whatever you want for it. Just FYI. 1 second. Why is this? Why is this not? Hello? This is the wonderful thing about Windows. Their start bar, even when you tell it to minimize, does not always. I guess you have to press the start button for it to minimize again. Charming. I guess that's why nobody actually does it. So, let's actually create a main function. And the thing is that in here, I don't think there's a way to run it. There might be. I haven't explored that. I haven't explored actually, running the breakpoint debugger from VS Code. That's on my to-do list. I am actually not sure at all how to do that. Supposedly with Dotty it's possible. I don't know. I don't know that the breakpoint debugger is working for Dotty yet, although I've seen a video by somebody showing it, but I have to double check all that. Anyway, the way that I typically do things is run main, first compile, and here we are compiling, run main, and actually it auto-completes. We have multiple main functions. We have multiple main functions. We recompile it. It will actually be able to tell you, oh, you've got multiple main functions. A couple of interesting things to note about Dotty. First of all, you can define top-level methods. And that's actually possible, and you can run them. Oh, wait. Oh, what's that string? The other thing, Dotty right now generally supports Scala syntax, or it's generally Scala with many more features that I'll go into some other time, because right now we're just focused on macros. The other thing that I'd like to mention, and again, this actually doesn't fully work correctly, but sort of the idea behind Dotty was that, oh, this is a lot of ceremony just to have a main function. So really what you should be able to do is something like this. You should be able to write any old function and do main on it. Should be able to compile it. Right, that doesn't exist now. And this will actually show up, right? My main top-level function, and that will actually work, except for when it doesn't. So, just an FYI. But anyway, so what else did I want to mention about this? Right, the other thing is that so let's make a function here. Let's make a function here. Sometimes control-click or go-to might work. Sometimes it's not, or it doesn't. It's a mixed bag. Sometimes symbol lookup works, sometimes it doesn't. It's a mixed bag. This is still very, very prototype-ish. Maybe on IntelliJ it'll be better. Probably on IntelliJ it'll be better. But I still end up a lot of the time, here, let's say, when I'm working on a bigger project, here in Dotty Quill, I need to actually look up this thing. I can't just control-click on it. I actually have to look for it, and typically, the object of this, or the class of this, or the function of this, if it exists. I typically have to go here. I mean, I've got this shortcutted away. Control-Shift-F is in my muscle memory. So, unfortunately, the niceties that we're used to with IDEs may or may not work with, as you experience this thing. It may or may not. So I'm not sure that will function. But anyhow, so let's take a look at how macros are written here. So let's try creating a macro. The key is that there's this new construct in Dotty called inline. What inline does, well, let's take a look at what inline does, actually. First, let me show you a macro, right? I'll show you the traditional definition of macros, and this is, similar to what you've seen already that I've shown you in Scala 2. Let's say my macro, and let's say it doesn't take any arguments. Actually, no. Let's say it takes an argument. Let's say it takes an argument, right? Let's say it takes a variable foo. Let's say foo is a string, or let's say it's a string, and it returns a string. And then the way that we do it is Dotty has two operators for macros, which drive all the things. It has this operator, which is quote, this operator, which is we've seen, we have sort of a rough idea of what quote is. What we haven't seen yet is this thing called splice. Let me very quickly explain what that is. Typically in Quill, we have this idea of, case class, person, name, string, age, int, val, people, let's say Joe's equals to query, quote, query of, hello? Tab size? Interesting. Query of person. dot filter tabs or spaces. You know what the answer to the tabs versus spaces question is? The ultimate answer to whether tabs or spaces are better. The answer is, why the hell do I ever have to care? Anyway. So filter p2p.name equal to Joe. So, all right, so that's going to be our Joes. And let's say we want to filter Joes over a certain age. Right? So now, let's call it drinking Joes. Drinking Joes takes Joes, and then it says filter. Here's a Joe. Joe.age greater than 21, greater or equal to 21. Now, here's our drinking Joes. The thing about this that we haven't really mentioned is that, wait a minute, we kind of assumed that this guy here, is a query of person, right? Because over here, he's a query of person. But is that really true? No, actually, that's a lie. It's quoted of query of person. Then how come we're doing filter? We can't really do that, right? Because this isn't actually a query of person. This is a quoted of query of person. Okay, then how does this work? Any thoughts?
Implicit.
But what does the implicit do?
It unquotes it.
It unquotes it. What does it mean to unquote? So there's this implicit, so Scala has this thing called implicit functions, or implicit conversions. Does everybody remember implicit conversions? Two seconds of implicit conversion review? Huh? What?
Yeah, I guess that's...
Yeah, a quick one would be nice.
Yeah.
Let's say I do something like case class person, name string age int, right? Case class Borg, ID int, age int, right? And let's say that I have some kind of, I have some kind of function that takes Borg. Let's say auto destruct b Borg. Right, and then auto destruct, let's say, what does auto destruct do? It just returns a string. Boom. The unit ID has blown up. Okay, auto destruct. Oh, whoops. B.id. Okay, so we have this function that takes a Borg. Let's say there's a person called Joe. His age, because he's a drinking Joe, right? Auto destruct. Can we auto destruct him? Auto destruct Joe. We can't auto destruct Joe because he's a person and not a Borg. But here's the thing. Anyone can become a Borg because anyone can be assimilated. But that requires calling an explicit function. That doesn't make any sense. Implicit assimilated. Let's call it assimilated. Implicit function that takes a person, and what does it do? It returns a new Borg, and let's say we need to assign him a random ID, and we need to import a random generator, blah, blah, blah. I don't really care, so I'll just say 1, 2, 3. And let's say p.age. So we have this implicit function that converts a person to a Borg. So now we can auto-destruct a person. Well, the proper name for this is person to Borg automatic, right? That's what that thing should actually be called. Okay, fine. By the way, I believe we can unimplicit this. Can we unimplicit this by redefining it? Yeah, we can unimplicit this by redefining it, at least in the REPL. I believe in Scala also. Person to Borg. That's an auto conversion. Now, here's the interesting part. Let's say that I do something like this. Remember what an implicit class is? Let's say that an implicit class is a way to do a decorator pattern. So let's say, what else can Borg do? Borg can, I don't know, shoot lasers. Okay. Let's say that it takes Borg shoot laser. Say it returns a string. Zap the unit. Has shot something. Okay? Well, let's say val b equals to Borg 456. His age, let's see, he's 500 years old. Shoot laser, right? He can do it. What if we try to do Joe dot shoot laser? Oops. Interesting. Shoot laser is not a member of person. Okay. Let's try, can we auto-destruct Joe? We can auto-destruct Joe, but we can't, but he can't shoot a laser. Interesting. That was actually not expected. Give me a minute to double check. Do I have to import implicit conversions? Sorry, just give me 1 second, because I thought implicit conversions. Let's see. Can he shoot a laser now? No, he can't. Oh, wait. No, I guess I'm wrong. I guess I'm wrong. There's something else that I need here. Now I have to look into that, because that actually should be possible. But anyway, beside the point. So, right, okay, if it's defined directly on the class, let's see, if it's defined directly on the class, let's define a function directly on Borg. Def, I don't know, heat vision, string, IC stuff. See if that does the trick. Let's redefine the auto conversion. And let's say joe.heat. Oh, okay. So basically, if you call a or heat vision, whatever, if you call a method, this is the interesting part, right? So now we've said that, okay, a Borg has heat vision. Okay? What happens if we do joe.heatVision? Well, again, Joe can implicitly be assimilated, so Joe has heat vision. So that way you can define implicit conversions, and what happens is that when you call a method on something, the Scala compiler actually looks at it and says, ooh, can I convert something to this that will actually make this statement make sense? Now, as you can imagine, this kind of behavior is probably very easy to abuse. So it is used very, very seldom. But when it's needed, it's really needed. Here's why. What are we actually doing to make our Joes spliceable into drinking Joes, right? Like, this is an actual quote. What we're really doing is unquote Joes. And what unquote does is that it takes quoted of query of person into query of person. That's what unquoting or splicing does. That's what splicing is in a nutshell. That's what that means. Splice means take a quoted piece of code and return it to a not quoted piece of code. What does this mean in terms of macros, right? We explored macros in Scala 2, and we didn't really look at splicing, or only sort of remotely. What does this actually mean, right? Well, there's another kind of thing that we've already covered. Let's say some string, and we say, okay, this is going to be some string is Joe. What is this? What does this mean? Let's say Joe.name. What does this mean? Well, this is the same thing. It means splice. Take the value of this string and splice it into this. So this is actually a splicing operator. With quasi-quotes, it's the same thing, where if you have some kind of macro, and that there's some kind of tree in here, or let's say a type tree, an expression of string, or something like that, and then, let's say this needs to return a person, and then, well, we can create a quasi-quoted block, new person, right? and say, excuse me, this is a, what am I doing here? Let's say this is a macro that takes an expression of string, which is a name. Let's say this is our person, and we take name and we splice it in. So the actual code that will be returned from this macro, right, when we actually call it, the actual macro, when we do that, what will it do? What it'll actually do is it'll take this string here, or it's not necessarily a string. It could be someplace .get name or whatever. It will actually run this thing here. This thing here will be converted to an expression. What does that mean? Imagine when this function gets kicked off, this thing will actually get passed as a Scala expression into here, right? As some kind of something that looks like this, which is actually of type tree, or of type expression that yields a string of some kind. Then this whole thing that goes into here eventually will get spliced into this place here, and then once the splice happens, well, guess what? The actual code that gets returned, once the splice actually happens, will, of course, be this. This will be your code, or once you remove the quasi-quote, this. And so this will actually get spliced in directly no, that's my example. This will get spliced in directly here when the macro gets invoked. That actually gets spliced into there. This is what your new Scala code will actually be. Now, this is how the process of writing a macro actually works. Except for that in Scala 3, instead of quasi-quotes, there's a quotation operation. So this is going to be something like that. So this is a quoted piece of code. You can imagine something like that. This is what a quotation looks like. So it's basically the same darn thing, except for the fact that now it's not a string, now it's legit Scala code. The other thing is that what about the $sign? And I've kind of glossed over the fact that in Scala 2, the $sign for splice, in a quasi-quote here, here we go. How do we do this? Yes, here. Right, the splice that we did here, right, and ultimately over here where we spliced this expression in, this $sign is the splice operator from a string, or what is basically a string. because that's what quasi-quoting is. It's really a string. Or at least it provides the facade of being one. In Dotty, when you do a splice, you still have this $sign thing here. And what you put inside is a quoted block. Now this is actually kind of interesting, because there is one more thing to consider. Let's say that you have some quoted code. Blah. Eventually you need to put it into some variable. Blah. Okay, this is quoted. What's this? Expr of string. Okay. Well, but this is a string. How do we get from expr of string to string? Ah, splice! Right? That returns a string. Right? Splice, and quote are sort of like opposites or duals of each other. Right? What happens if you quote again? You can quote this whole thing again. And what happens? Well, it'll just turn into an expression of string again. And guess what? We could splice it again. And again, it turns into a string. So you can quote splice, quote splice, quote splice. And so actually in the Dotty macro syntax, this most outer thing is actually a splice. The most outer operation is a splice. Right? Because you have as many splices as you have quotes. Because at the end of the day, the type of the thing that's inside has to come out of its little expression cocoon, right? So you can take it out of the cocoon by doing splice, and if you put it back into its cocoon, you have to do quote, but eventually it's got to come out of the cocoon. You can have as many cocoons as you want in, between it and the outside world, but all those cocoons need to be spliced. So that's why, actually, in a Dotty macro, the most outer thing that you define is this. Now, once we have that, let's actually define. So this is our header, so to speak. Not really, but this is our header, let's call it. Now we actually define the function that we call. So let's say my Mac impl. Let's say it takes a foo. Ah, but here's the thing. It takes foo? Not really. It takes quoted foo. It takes a quotation of foo. Okay, let's define this guy. Define this guy over here. Foo. Ah, but we quoted him, right? So he's going into his cocoon. Expression of string. And what does this thing return? It's a string, okay. So again, we have to cocoonify everything. So here's expression of string. Now, let's do something very, very simple in here. And let's just print this guy over here. And I think we can do, oh yes, excuse me, there's one other completely completely happenstance requirement of Dotty macros, which is that you need something called a quote context. Quote context. And you need to import this thing, qctx.tasty. I think it's like that, but I don't remember it off the top of my head, so let me just quickly qctx.tasty. Blah, 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 blah. Okay, I think that should do the trick. Now, all that we want to do at this point is print this thing. And let's do foo.show, I think. Let me just quickly check. Yes, it's .show. Yeah. And then let's, I think you need to, I'll explain what this is in a minute. Sorry. I think I need to do this as well. And let me just double check. There's a little bit of syntax here that I'll explain shortly. Let's just return foo. So this is how Dotty macros are written. And it's all based on the fact that we have this splice, a quote and splice and quote and splice and quote and splice that goes out and out and out and out. So this is the splicing operator. In fact, remember that I showed you up here in Quill drinking Joe's, right? This is actually that. Right? In Dotty, we call this a splice. Oh, and the syntax would be that. Now, actually, again, remember how when there are no dots, when it's just one single variable, you can even do that. Anyhow, so this is the long and short of quoting and splicing. Before I go forward, let me stop for questions. Sorry.
No, this is crystal clear to me.
Yeah, all
Yeah,
good.
it's making sense to me so far.
Okay, cool. All right. Anyone else? Anything else at all?
No, sir.
Okay. So let's see if this thing will run. Back in Scala 2, remember how it was important that our macro, the actual function that calls it, or the invocation, and the actual macro definition is in a different compilation unit. That is to say, either it's in a different project, or it's in, or it's in your src main test, as opposed to src main Scala, because src main test and everything inside there is a different compilation unit from everything inside src main Scala. Basically, if in Scala 2 you want to use a macro, that macro's got to be coming out of a class file, right? It's got to be coming out of a dot class. That thing has to exist. In Scala 3 or Dotty, that requirement has been relaxed a little bit, so long as it's a new file. And so Dotty 3 is a little bit more intelligent. It's like, oh, we can turn this file into a dot class file before we run the other file, right? Because we can compile this thing before we compile the thing that's going to use it, Okay, a little more intelligent. Let's say use my first macro dot Scala. And project package org.stuff object use my first macro. Why is this? I said 2. User my first macro. Okay, let's go with user my first macro. Def main args array string unit my first macro dot, what did we say? My mac. And let's say hello. And let's compile this thing. And then let's print the output. Let's compile it and see what happens. Let's see if it'll work. Ooh. Oh, we need to import some more stuff. I forgot to import some more stuff. We need to import Scala.quoted. Let's see if that'll do the trick. Voila. Okay. So this has been printed during compile time. In fact, we can do, now we are showing, let's try that again. Now we are showing hello. But we don't want to do show. We want to do show raw. Let's give that a shot. How do I show the expression tree? Yes. Yes. In Dotty, there is an additional thing that they created. The additional thing that they created was the fact that expression of string, which back for Dotty 2 we said is the same thing as a tree, where a tree is just an untyped syntax tree. The way that they've decided to do it is a little bit different. See, in Scala 2, tree, the definition of a tree, the abstract syntax tree, when you're inside a Scala 2 macro and you're using a tree, like here, this is the actual syntax tree of Scala itself. And for that reason, it's the equivalent of an expression. So this is interchangeable with that. In Dotty, it's a little different, and I don't want to get into the details of it now, but in Dotty, what they did was they created an abstraction of a syntax tree. So it's not the real syntax tree that the compiler sees, but it's an abstraction of the syntax tree that the compiler sees. And it's, again, based on some new cutting-edge research that they've been doing for a bunch of years about a new way of doing metaprogramming, which is you compile, or you have a facade of a abstract syntax tree that is actually not an abstract syntax tree, but an interfaced version of the abstract syntax tree. And that is actually how, in the future, they want to do things like guarantee that code is portable across many different versions of Scala. One of the key sort of problems with compiled code is that compiled code might not necessarily be portable across different versions of a library. Say that you use a library that, let's say, uses let's say some serialization, right? And it has a method there called .toJSON or something like that. And then let's say that you want to move to the next version of that library, but you want to move to the next version of that library from code that's already been compiled and already uses the previous version of that library. So let's say, for example, that you're using some kind of, RPC remote procedure calling code, and inside of there, the remote procedure calling code relies on some version of the JSON serializer. So then you have a toJSON function. Well, guess what? You want to run the new version of the serializer. And let's say the toJSON function adds another argument. Well, then you're screwed. Because guess what? Everything's already been translated into bytecode, so you can't really do that. So we have this sort of interesting dichotomy where, on the one hand, there's source, on the other hand, there's bytecode, and there's really nothing in the middle. When you're in source, you can change anything you want by hand, except for that it's very difficult for machines to manipulate source code, because they have to parse it all first. On the other side of the spectrum, you have bytecode, which machines can run, but it's also very hard to manipulate in a program in a systematic way. So what they figured out is that, wait a minute, we gotta have something in the middle. So our compiler should actually be able to have an intermediate phase, which is syntax tree. I want to have not a bytecode file, not a source file, but a syntax tree file. And then, if the library, the guy who wrote the serializer, can then provide a utility that automatically upgrades all the code. Because you're in syntax tree land, and he can just write a bunch of syntax tree transformations that will upgrade the old code into the new code. So that's the whole impetus behind these kinds of abstractions. I can talk about them more in the future. I don't want to spend more time on this now. The trick is that there are some other things that you need to do. You need to do this thing called .unseal. What this thing does is that this actually translates this thing here. Can I see the type on this thing? I should be able to see the type on this thing. Let's see. I don't even know why I can't see the type on this thing. So what this will do is that this will convert this expression of string into tree. So then this should actually show me the syntax tree. Let's see if it does. Oh, wait, no. I think we need to change this file. Still doesn't do what I want.
Is it show raw now?
Let's try it. It's worth a shot. I don't think there is a show raw. There might be. No, there's no show raw. 1 second. Not what I want. Oh, I think it's show extractors. I think that ought to do it. Okay. So this is starting to get interesting. Okay. So we have this literal. Okay, so it's a constant. It's a constant string hello. We've seen a literal, right? Because it's literally the expression hello. And then there's some more stuff here. Now we can actually, I believe we can make this a little better because we have Quill imported. We can do, let's make a line break here, make it io.getQuill.util messages.qprint. I believe we can pretty print this. Let's give that a shot. Okay, there we go. All right, so now we actually have colors, and we're in slightly better shape. So this is actually interesting. There's some other thing here called inline. What does that mean? And we've thought about that. Let's think about something else, which is what happens if we have something like this? Instead of putting the string directly in here, we do something like val v equals to hello. And then let's put v into here. See what happens now. Oh, wait. Ah. Oops. There we go. Okay. Well, v is an identifier. And that sort of makes sense, right? V is an identifier. What is that? What is this inlined thing? So, inlined, if you think about it, inlined is the representation of that. It's the representation of an inline expression. For example, let's say that we want this to be, so, okay, sorry, one second. We're passing this here, right? We're passing this kind of identifier here. Let's say that this variable itself, let's say that this is a function instead, right? That should be the same thing. Output 3, output 2. What did we break here? Oh, right, VV. And well, this is interesting. Identify. So VV was hello, and we pass foo inside, and now it's an identifier which is foo. Okay, the plot thickens. Let's try one other thing. Let's try defining my mac2 that corresponds to my mac impl2. And then we say that this argument itself is also inline. And then let's call it VVV, output 3, my Mac 2. Let's try that. What did we break on? Oh, VV is already defined. VV is already defined as method VV. Why did we break here? Oops. Oh, right. Oh, oopsie. We don't need this middle one. There we go. Let's try that. Okay. Now we're getting somewhere. Oh wait, no, not what I wanted. Ident of VVV. My first macro. And now we need to do one more thing, which is, okay, this is ident of VVV. We've shown inline. And now we need to do one more thing. Let me actually quickly check something. Oh, right. Inline def. So our expression, wait. Oh, that's what I wanted to do. Let's try compiling that. We need to change our user code for a second. In order to recompile, we need to change the user code. Okay. This is what I wanted. So, we have this notion of an inline variable. You can actually define variables in line here. And so in this case, we've defined a variable as being inline, which means this thing, whenever this expression actually happens, this gets swapped in instead. And by the way, let's do it up here too. What happened was, over here, this was some kind of function. Notice how the argument itself, in order to get swapped in, has to be defined as inline. If it's not, then guess what? What does this mean? This means the expression foo. Well, that's why we have identifier of foo here. It's just the expression foo. Except for when it's a value, when it's a literal, right? Still, this is a value, so we're using the value here. When we actually put a string directly in here, right? We actually invoke this thing with a string, then okay, right? It actually puts the string into here. Because remember, this is like quote. Right? Whatever goes in between this parenthesis and this parenthesis physically gets swapped into the macro. Right? We're not like evaluating things first. No, this expression physically gets shoved into here. However, if it's not a string, if it's a variable or an identifier, right, then it's the identifier v that gets shoved into the macro. Because v is literally what's between the open parenthesis and the closed parenthesis. The curious part is this. Why the heck is this ident_foo? I'm actually not sure. I don't know why this is behaving this way. what's interesting to see is if you do something like inline here. Let's make VV inline. Aha! So now we've actually swapped in this whole thing into this variable, right? Because that's what inline means. Take this thing and swap it into here. And then we take this thing and swap it into here. Okay. Interesting. In this second macro, we've gone one step further. And we've said, okay, now we define our argument as being inline itself. What does that mean? Well, we got to go one step further. Let's say that this thing itself calls, and in fact, let's leave all of this up here and let's define a new function. Let's leave all of this up here. We can actually comment it out. Let's say that we have a new inline, second, and let's say this inline is actually that. So now we have a transitive inline, right? Will this be swapped into this, which then will be swapped into this, which will then be plugged into here? Let's have a look. Okay. They seem to be treated equivalently. Sorry, this is a little garbled because the compiler likes to print some text in the middle of the output. Interesting. They seem to be treated identically.
Ooh, can you replace the second with double V?
Ah, excellent thought. Cyclic error. Well, that makes sense.
Yeah. Oh, actually, what about how about you assign triple V? How about you assign triple V as double V? Like, triple V equals double V.
Let's try that.
Oh, I meant the other way around.
Triple V is double V.
Yeah, triple V. Yeah.
Good. Give that a shot.
Well, that actually does replace it. Cool.
Right? So it really is transitive. Now, let's see if we can go one step further. And let's say that the output, of here is also in line and into here we plug that. Now we're starting to see interesting things. Okay, so everything was swapped in the way we would expect, but now we're swapping one thing inside of another. We have an inline. So this, let's see, this was when we called my macro in there. And then we swapped it into output 2, which was in line. Output 2 is in line Again, ignore all this, please. Oh, and then what else happened? Ah, but remember that we assigned this to VVV, which means that this was assigned there. Now, curious, what happens if, by the way, again, this argument is in line, this is not. Ah, notice my Mac. Notice that? The argument that you actually pass inside is not in line. What happens when we inline it? What happens when we inline it? Interesting. So it's still showing up.
Oh, don't you have to change the user
Oh
my
yes,
first macro?
excuse me.
Yeah.
I do. Yes. No. Yeah. Output to vlist. Output to vlist. Same thing. It's still in line. Let's have a look. Okay, this is defined as inline. This is defined as inline. We have output 2 being created from here, VV being created from here, and this is blah, blah. Interesting. And, oh, blah, blah. Okay, blah, blah is a string, which is coming from second. And look at that. We actually got there. We actually got all the way into this. So what does this actually mean, right? So what we did was we actually swapped this thing. We swapped this thing into this thing, into this thing, into this thing, into this thing. So the whole result of output 2, the result of output 2 was that. That's the syntax tree. And then what happened? Well, we took all of this stuff and we swapped it into there. Now, we want to go one step further, though, right? We want to, because we know what all of this is going to be, right? We want to collapse the entire macro, right? Because we don't actually need this. Yeah, we have a macro function that we invoked here that the language knows about. But here's the thing. The macro function just returned what we were taking in. But again, the fact that we invoked it is not lost in the syntax tree. So let's just quickly break this down again. Let's break down what's going on. What actually happened? Let's break it down again. In the beginning, we had this. Then we swapped this thing into here, and we got that. Then, what's the next step? We swapped this thing into there, and we got that. Interesting. What's the next thing? Well, we then took this and swapped it into there, but the fact that this macro thing is here and it exists was not lost on us. And so we know that this whole code here went into a quoted expression. So let's actually make that the next stage. We then came to the understanding that this whole thing here is a quoted expression. Okay? Once we understood that, the next step, and we could take this out now, because we don't care about it anymore. In fact, we can remove that from there, remove that from there. It's just all noise. Okay? Now, next step. This whole thing, the fact that this whole inline thing, what is this? Output 2 equals blah, 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 blah. Well, that is that. Let's have a look. There we go. The inlined block that represents this thing is actually that. This is this. Next step, what happened? We then took this whole thing and we swapped it into here. And now, once we swapped it into here, we then again quoted this whole thing, because again, this is in line. But again, you can't have a quote inside of a quote, right? That doesn't really work. So the way that we present it internally is that it's actually flattened, and there's this thing here which is in line. So this actual double quote thing is flattened. But it's just a detail. So now, what is this whole thing? This whole thing is that. VVV, and then let's see what's all the way outside. Okay, good. And now, once we have this whole thing, well, what do we do next? We just take this whole thing and we shove it inside of here. And then inside of here, inside that macro, meanwhile, inside of this macro, what do we do? Right, this is the input. This is the input string. We say print, or pretty print, whatever, this input. And so, well, guess what? There's one more level of inlining that happens after this, right? Because remember that input is actually in line, okay? Just something to note. Which is why we have the most outer tree, which is this whole thing. So this is how you can progressively inline stuff. And Scala, the compiler, actually understands every single level of macro call that we had in between. And it gets that. But, okay. So we did a bunch of fancy stuff, but here's the thing. This whole expression evaluates to this, right? Because, okay, we've got these fancy macros here that are printing stuff, but we're just returning the input, right? So this whole thing should evaluate to blah, blah, right? And that's what, and guess what? If we actually run it, if we actually run this thing, and, oh, we need a main function in order to actually run it. If we actually run it, well, let's recompile first. Okay, we got what we expected again. Run main. Oh, we're printing it a few times. Let's take out the intermediate print lines. Let's take out that. Let's take out that. Let's take out that. Let's have one print line, right? The whole thing evaluates to blah, blah. But here's the thing. What we actually want is all these expressions inside of this macro to collapse into the initial value that we passed in. What we really want to do is we want to be able to say foo match, or in this case, foo.unseal match, and we want to be able to do case literal constant string, and pull out the string and do something with it. We want to do something with it, but we can't, because the thing that's coming inside is not literal of constant of this, right? It's this whole giant thingamablob. So how do we collapse everything here? So that's why there's another thing. There's another thing called underlying argument. Let's see if that'll do the trick. And yes. Typed literal. Why is this? This is literal of that. And one second. Qprint foo.unseal.underlying argument. And why is this typed? Why is this typed? Interesting. Let's try underlying. No, that shouldn't matter there. I'm not sure why it's saying that. Let's see, it's yeah, I'm not sure why there's a typed node around it. But let's do something else. Let's actually try dot show extractors. Let's try doing that. Ah, yes. Okay, fine. So there's... Okay, so it's actually a constant blah blah, and it seems to be typed as a string. I'm actually curious what happens if we do underlying argument here. Let's quickly have a look at that. Okay, so up here it's doing literal. So this is actually what we're looking for. So underlying argument, what underlying argument does is it collapses this entire tree and just goes inside and inside and inside and inside and inside all the way down to this last thing. Now I expected it to just return that, but it looks like it's also doing that. What is this thing? Right? Well, typed is the equivalent of doing something like this, where you do foo string. That's a type ascription. What kind of language, what's the AST that this gets translated to in the language? Well, string is going to be literal, right, of foo. Could be constant, depending on a few things, but the fact that this is a type ascription also is typed. That's what that means. And what's the type? It's a string type. And there's a, usually this is like ident or type ident, something like that. Or basically it means a class. It's a class of some kind. So that's what we've translated into. Now, right before, the first time we went into here, so this was when we went into there, it's interesting to note that this was not typed, right, when we printed it out from here, because now we're printing out underlying argument from here as well. This was not typed yet, but when we went into the second macro call, it became typed, because there was a type ascription there. I am not 100% sure why. Probably has to do with this variable. But anyhow, we can parse this thing. Let's do something like def parse function. And this takes an expression string. And what it does, let's just say it will return either an optional of a string. So if the string is parsable at compile time, it'll return it. Otherwise, it'll return none. Okay? So let's say expr match case typed. It could be wrapped by this weird type node. And if it is typed, it's going to be value TPE. And then we just recursively call it value. Ah, but hold on a minute. This is not going to be expression of string anymore, because we unsealed it, or we have to unseal it in order to be able to process it this way. So it has to be a tree or a term, I believe. So let's try that. And then, finally, if we get a literal, I believe you just need literal value. Let's make sure it's actually a string. Then it returns some of the value. So basically, we just did something that needs to get past this thing here that could be wrapped. Okay. Let's give that a shot. Let's see if that works. There's going to be an option of a string. Parse function of foo.unseal dot underlying argument. Okay, let's see what happens now. Compile times string match case sum of value
I'll be right back.
Sure. It's going to take a second anyway. The expression foo is a compile times string. Case none. The expression foo is not a compile times string. Let's see if we can compile this thing. Oh, looks like we have an error. Oh, oops. It actually needs to be literal of constant. Let's try it again. There we go. And expert tree is a compile times string. Ah, ha, 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 ha. We actually want to show it. So let's do dot show. And I think we need to modify to recompile, although I'm not 100% sure you need to in all situations. But anyway, okay. This is the actual expression. So notice how I said before that the expression, which was originally blah blah, or in this case it's blah blah, when we passed it into the first macro, it became that, right? It became this. Well, right, this is actually it, right? When we print our expression, when we say show it, it's actually telling us, guys, this is what it is. So it's a string with a type ascription, right? This is just the package name. Okay. So we actually have a compile times string. Now, one other thing that we've got to mention is that we only leave room for two cases, right? If it's typed and it's a literal. So if we actually type a case that won't match it.
I'm back.
Oh, welcome back. So we just got our matching thing to work. So let's say we do val v equals to something else, and we actually pass that into here. Well, what happens now? Whoops. Match error, because v is an ident, right? So we, and this is, it's especially important. It's important in all code, but especially in code that runs inside the compiler to get every case of match. None. Let's try it again. Voila. The expression v is not a compile time string, because it's not. We don't know what the value of this is during compile time.
Oh, Alex, why don't you have to change the user my first macro there?
Huh?
Like when you made the change in when you added that case, but you did not make any change in the in the first macro in the file. How did that work?
Oh, this guy?
Yeah.
Oh, well, we're not using him. We just passed it directly into the second one. We just made an example string that we passed into the second one. Right, I'm just bypassing this entire thing completely, and I'm like, okay, what happens if we just pass a random variable inside of here?
Yeah. Oh yeah, no, that's not what I'm asking. I'm asking like how did it compile without you changing anything in this file?
Oh,
Yeah.
Oh, without changing anything in this file. Oh,
Yeah.
here's why. Here's why. Because if you notice, the previous time it compiled, there was an error. And so if the previous time you compile there's an error, it has to attempt to recompile the file because it doesn't,
Oh, okay. All right.
right?
Yeah,
It's
makes
only
sense.
when you have a
All right.
successful compile that you need to change something inside of it to force it to recompile. If it failed, or if it failed, then it has to try it again.
Yeah, all right. Makes sense.
Okay, so as opposed to if, yeah, that is a very important tidbit. I just realized that is actually not entirely obvious, but anyway, so
Sorry about that.
there we go. So now, when we actually have a lineage of inlines all the way back here, so that got substituted into that, got substituted into that, got substituted into that got substituted into this, guess what? We actually know what the original expression was. Okay, interesting. Now, again, let's just say that this is not a val, but an inline def. And let's put it in. Well, look at that. Now it's just the string something else. Looks like there's no type ascription. And guess what? It's a compile time string. So our recursive function doesn't recurse because it's just directly a string. So we've just covered a whole bunch of stuff here. Let me pause for questions.
Small one. In the when you're defining the macro method, how important it is to how important is it to declare inline parameter?
Okay. So let's explore a little bit. Let's see what happens. Let's see what happens if, let's do VVV. Let's see what if this is not in line. And, oh yeah, we think we do have to force it. Did we? Oh no, we did change it. Whatever, it's fine. Looks, okay, no, this was the same thing that we got last time. This was the same thing that we got last time.
Like I know that there's a change in the AST that we saw last time. Like there's an extra inlined. I remember that, but
So we've deleted the inline in this first one. Let's delete it from the second one. Okay. So we've deleted it in both. And it looks like it is completely unnecessary. Unless, of course, we decide to show what the tree looks like without underlying argument. If we just do that. So let's try without underlying argument, what does the tree look like? Here's what the tree looks like without underlying argument. Okay. So without underlying argument, but hold on. We removed both inlines. Oh, let's put these two things back. Excuse me. We removed both inlines. And our expression is faux. We removed both inlines, so effectively, stuff is not substituting. What's
Oh.
happening is the thing that's getting inlined is the thing that's getting inlined back from here, which is this variable here. Right, this is the tricky part, right? This is in line, so it goes into here. This is in line, so it goes into here. What's the first thing that's not in line? Foo is the first thing that's not in line.
But it's part of the macro, so it should be fine, right?
No. Well, again,
No.
foo is quoted here.
Oh wait.
So foo is actually a quoted variable. Let's try what happens if we do inline here. Still foo.
Oh wait, don't you have to change the first macro?
Huh?
Don't you have to change the first macro? The
We
other file?
changed just the first one.
Oh, okay.
It's still foo. Why is it still foo? Because again, this gets substituted into this. This gets substituted through here into this. This then gets substituted into here through this. This then goes into this. What's the first non-inlined thing? It's this guy. All right, let's even change it. Let's do foo with 4 O's. Let's see what happens. All right, I need to substitute it some more. Foo with 4 O's.
I see.
Let's get rid of the inline up here so that the first thing that happens is the first non-inlined thing is this variable itself. It's still 4 O's, but.
Wait, again, don't you have to change the other file first?
I think you're right. Let's see if that, no, but that'll still not do it. That'll still not do it, because again, let's take this exact same logic, parse function. Right, so what happens, right? What happens in this situation? Again, this becomes substituted for this. This becomes substituted for this, and then substituted for this. This thing in here will not be in line. So this will be the variable FOO. But here's the thing. This will be in line, then this will be in line. This gets substituted into here. But for a second time, FOO will not be in line. So it will be the last non-inlined thing you had. Right? You keep inlining until you can't.
Oh, so what if you inline this parameter, the FOOO, but not the just FOO? Here you actually see. That is so strange.
Let's modify this just in case. That's interesting. I'm actually not sure why that is. Let's take our parsing code and let's put it into our first macro.
Yeah, because foo is not.
Yeah, I'm not sure. It's an interesting question. Let's take this stuff. Let's take this stuff and use it in this guy up here. Let's see what happens. Oh, wait. What did we just break? Oh, right.
Oh, FOO.
Yep.
Is up. Yep. Yeah.
And, ooh, interesting. And hold on, let's modify this. Interesting. So what's happened, what's happened is we've swapped in the thing in the first one. Let's see. Da, 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 da.
Oh, in the print element, can you just add in whether it's in macro function 1 or macro function 2?
Oh, sure.
Like yeah, just Mac 1, Mac 2, perhaps, yeah.
Good point. In fact, let's add it to all of them.
Oh yeah, that would actually be cool.
See? Aha. So in our first macro function, why is this? Oh. See, Scala actually does. Scala will have a mode where you can do indentation, meaning something like Python, which half the community loves and the other half hates. Anyway, interesting. So our first thing here was not in line. I wonder why that is. Let's see. What happens if we take out underlying argument?
And make the change in the other file.
Yep. What happens if we do that? Okay. Let's see. So we have hello. Oh, let's actually take these things out because they're just noise at this point. Okay. So we have an inline block that's going into the first one. Okay. This is not an inline.
Yeah.
Okay. And then we have this second thing here, and the second one is inline. Oh wait, hold on. We forgot to remove underlying argument from the second one. Excuse me. Let's remove that for a minute. Let's remove underlying argument from everything. There we go. There we go. That's what I wanted. Aha. So we remove the underlying argument, and then we don't have inline in the first one.
Mm-hmm.
But then we do have inline in the second one. Interesting.
Yeah, but that's expected though.
That's expected. Right? Let's add inline back to the first one. Output to VVV inline.
Did it change?
Nope.
It didn't.
This is interesting, actually.
Whoa.
It looks like when you're, it's only when you attempt to inline things multiple times, and when you need to actually start keeping track of multiple inlines, that this happens. Now, let's let's try something non-trivial. Let's try something non-trivial like that. And let's try modifying it. Let's see what changes. Well, we've already modified.
Oh, you already did. Yeah.
Ah, okay. So the compiler was smart enough to know that the thing we're appending is also static value. Let's actually do something. Something that the compiler doesn't, that's not inline, therefore the compiler has no visibility into it. Now it gets consequential. Because now we actually have to start inlining. Oh, right. We need to take everything that we had before. What did we have to do with this? We had to take this. We could substitute it into here. We tried to substitute this into here. But we can't. We need this expression. So now we already need to start tracking stuff.
Wait, I don't think I'm following.
Let's have a look. This is, again, you really have to understand this, you really have to get your brain thinking like the compiler. Which is hard, because we don't think like compilers, we think like humans. Okay. Well, we know what happened when this thing wasn't here, which is this could be trivially substituted into this. This then could be trivially substituted into this. This could then be trivially substituted into this, and everything was wonderful. But now we added something else here that the compiler had no access to. What do we do? Well, now what ended up happening was this. Initially, we started with this stuff. Initially, we started with this stuff. And then once we got through this stuff, what happened? Well, this needs to get here. This needs to get here, so this is an ident. Okay, fine. Can't do anything about this. So this is just going to be an ident. Nothing to do there. Okay. This, what about this whole thing here? How do we substitute? The second that we need to start tracking inlines, we can't just shove this thing into here anymore, because this thing could do some other stuff that could modify this here. Right? You could do something here. Imagine for a second that something else was some definition that was mutable, that was based on some data structure. And then inside of here, we did, let's say, get something. We did that, and we did modify something. And then by the time we got over here, this thing is important and would have changed this. We're already dealing with stateful code, so you can't just swap this thing into here anymore. You have to take this whole darn expression and shove it into there. Does that make sense?
Yeah.
Right? So the second that we can't do trivial swaps, well, everything sort of goes to hell. Because again, we don't know what this is. This could modify what comes out of here. Which means that this whole thing here needs to itself get quoted. And only once it's quoted, can it be shoved into there. And only once all of this is quoted, can this then be shoved into there.
But all those quotings are still implicit, right?
Yes. Now again, let's look at why this has to happen, right? Imagine that in here we do something. Let's say we assign it to. We say this is going to be get Joe's name, and this calls some remote database that has some state, and we say this is blah blah blah. Oh, and by the way, before we return blah blah blah, change Joe's name to Jack. Hack. Freudian slip, right? So guess what? By the time this thing in here, or let's say, yeah, by the time this thing in here, which is actually a function, this is a function that just calls this, by the time this stuff gets called in here, and let's add parentheses. The Scala convention is when you're dealing with stateful code, you add parentheses around it. A function that has stateful code has parentheses around it. When this thing is called, over here, it'll call Joe's name, but guess what? This thing here, before returning blah, 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 will modify Joe's name. Which means that we already have to take this entire expression, here, and we have to quote it. Right? This whole thing needs to be quoted because this entire expression actually needs to get shoved into there. Right? We can't just shove this value. We need to put the entire expression in. Which is why what we then do is we then take this entire expression and we have to shove it into there. And now, when the compiler will actually evaluate this whole thing, it will remember, oh, we have to run that function first. Before even evaluating this thing, we have to run this function first. And then let's imagine that we did something even more interesting, right? And so now, okay, it's fine. It's fine, but what about this thing? This thing could also make yet another modification.
I will be right back.
This can make yet another modification. So what does that mean? This thing, we need to keep following this process. We need to keep following this process of quoting stuff and shoving it, and quoting stuff and shoving it, and quoting stuff and shoving it, until the end of the universe. And then finally, this whole thing here is going to go inside of there. Because again, you can modify other state in between. For example, here can have other functions that modify state here as well. Modifies the state of get shows name, which will be returned from something else. Right? Right, and only then do we call this thing here. Let's can put it on the next line. So that's the tricky part. Understanding why things get inlined like this. Because stuff can happen in between. But again, if now we actually have this being in line and this being in line. Let's stop that from happening. And let's see what happens. Oops, and need to modify this.
I am back.
Welcome back. Ah, we've removed the inlines, and now stuff is different. Now it actually can't work past the variables foo and foo that we've declared. Because there's a whole bunch of stuff that happens in the middle.
Where again did you remove the inline?
From the parameter. Here. And here. Again, let's add them back. Let's compile. And you see the entire tree gets propagated all the way through.
I see.
Now, let's remove them. Let's remove it from the first one. Gotta force it to recompile. So, and then inside of here, aha! We can only get as far back as foo, because foo was the first thing not in line, right?
Yeah.
We went from here, shoved it into this. Ah, but again, we needed to shove this whole expression into here. And then this whole expression we needed to shove into there. And guess what? Foo was the first thing that wasn't in line, so we couldn't go any further, which means that the deepest thing we know about is foo. Ah, but what happened when foo was itself in line? Well, then we could reason back as far as blah, blah, blah.
Add something else.
And something else, yeah. Right? We could reason all the way back. And again, make them both not in line. Make them both not in line. We can't really reason about anything. Now again, let's make them both in line. What is the purpose of underlying argument? Let's see what underlying argument does. Let's add it there. And we also have to add it there. Add it there. Add it there. So we've added it to all the places. Oh wait, we have to change the code that's using it. Well, look at that. Underlying argument has collapsed all of these intermediate, underlying argument has collapsed all of this intermediate stuff. All this intermediate stuff is gone. And it reduces it. And it reduces it to just that. Just our initial expression. So underlying argument collapses the series of nested expressions. Which, by the way, if you are doing stateful code, there could potentially be some danger there. Again, it's like more complicated what happens. The consequences of it are more complicated, but it could potentially be dangerous. But of course, Quill's code, Quill's internal DSL code, is all stateless, so we don't worry about that sort of thing. So this is the point of underlying argument. In fact, we use underlying argument almost everywhere. We use it almost everywhere. So most of the expressions that we use are going to be collapsed with underlying argument. But that's why it's important to know that when you're dealing with macro code, to collapse things, you need underlying argument. So that's what's necessary there. So, now, so we sort of started writing some parsing code, and let's see, I guess I'll stop here for questions. I think I was going to actually go into introducing the equivalent in Scala 3 of quasi-quotes, but I think we should save that until next time. I think I've overloaded your brains for one night enough, and then we'll go into actual quoted parsing on the next evening. Does that make sense?
Sounds good to me.
Okay.
Yeah, that's good.
That sounds good.
Okay. Any questions before we go?
I guess that's a no.
Okay.
Yeah,
Yeah, none for me.
you don't have any.
All right. So, when's a good day for you guys? Does Sunday evening work?
Yeah, that's good for me.
I think I can do Sunday.
Okay. I have to check if Sunday would work. If Sunday does not work, does Tuesday evening work?
Yeah, Tuesday definitely works for me.
Okay. It'll either be Sunday or Tuesday. I'm going to double check and figure it out, and I'll update you guys when I figure that out. All right. So I hope you've gotten sort of some sort of sense of how this whole inlining stuff works. It's sort of this is a very cutting edge sort of metaprogramming system. This sort of way of reasoning about things as sort of these quotes and splices is, it's new. The consequences of this kind of expressive power, the software industry hasn't really comprehended yet. So this is sort of the tip of the spear, proverbially. But anyhow, all right, guys, have a good night, and I'll talk to you soon.